Alright, this relates to 6.1 law of sines. And I think the best way to do this is to give you one example from each of the three cases. So number 25 is one of the homework problems. You're given A equals 110 degrees, little a, which is the side across, is 125, and you're given B as a side, which is 100. So if we draw out that triangle, I recommend you draw out your triangles. You have A, B, C. Angle A is 110, side A is 125, side B is 100, and we have to solve for the triangle. Now this is the ambiguous case because we have two sides, S, S, and A. And remember, S, S, and A means we could have one, two, or no solutions. So the first thing we do is we run the law of sines against this angle and the opposite side. So the sine of 110 over 125 equals the sine of B over 100. And when you put that in your calculator, you'll get B is a valid angle at 48.74 degrees. So we know it's not the no solution case because we did get a valid sine here. The sine of B is between -1 and 1, and therefore B is 48.74. So we're either dealing with one triangle or two triangles. Remember what we do is we take 180 and we subtract this answer from it. And when we subtract 180 from 48.74, we get 131.26. And so if we take 131.26 and add it back to 110, we're going to be greater than 180, meaning we're going to exceed the allowable degree total for a given triangle, because 131 plus 0.26 plus 110 is going to be 241.26. So we do not have two triangles for this very reason. So we're literally solving for one triangle. And as I said to you in class, I'd like you to make sure that you write it out like this. Now we know that angle C is going to be 180 subtracted from 110 minus 48.74, so you should be able to calculate angle C as 21.26. For sides, we're given side A at 125. To solve for sine B, to solve for side C, you're just going to use the law of sines. So you could solve for you're given side B is 100. All we have to do is solve for side C. Side C is right here. So we can use any of the A's or the B's to do that. We'll use B. We'll do 100 over the sine of 48.74 equals angle C, the side C over the sine of angle C. And when you solve for C, little c, you get 48.23. And so a complete answer would look like this. So again, we have the ambiguous case. We go ahead and solve for angle B. We see that angle B at 48.74. The supplemental angle that goes along with that is 131.26. Too big. So therefore we're stuck with one triangle. And then we finish out with the law of sines a second time. In number 27, you're given A equals 76 degrees, little a equals 18, and little b equals 20. Once again, this is the ambiguous case because we have an angle, we have a side, and we have another side right over here. So we run the same process. We'll do the sine of 76 over 18 equals the sine of b over 20. Okay, here to here, the sine of b over 20. Turns out that when you cross multiply, you get the sine of b equals 1.08. The sine cannot be greater than 1, so this is a no solution case by virtue of that very situation. In 29, we are given a equals 58, little a equals 11.4, little b equals 12.8. So we'll go ahead and create the triangle ABC. We have 58, we got 11.4, we have 12.8. We'll go ahead and do the law of sines. We'll get the sine of 58 over 11.4 equals the sine of b over 12.8. Turns out when we solve, we do get a valid angle for b of 72.21. Now let's see if we have one triangle or two. I'll go ahead and subtract 180 from that 72.21, and I'll get 107.8. And as it turns out, if I take this 107.8 and add it back to 58, we're less than 180. Therefore, this is also a valid angle. So we basically have a B1, and we have what we'll call here B2. So your answer is going to be two triangles, just like this. Now in the first triangle, the given is 58, the side is 11.4, and this side is 12.8. And the same is going to be true here. We don't change any of the givens. B1 is 72.21. We'll put that here. B2 is 107.8. We'll put that here. Okay. We can solve for angle C by using 180 minus these two. Okay, and when we do that, we get 49.79 on this one, and we get 14.21 on this one. Then we use law of sines again to solve for the remaining side of C, and we get 10.27 here, and we get 3.30 here. Again, that was done using the law of sines. So you will circle, or I should say box in, the answers for the two triangles. So those are all three cases for SSA. The other scenario for law of sines, which is angle side, is much easier. There's always only one answer. The only time you look for the ambiguous case is when it's side angle. But for all other uses of law of sines, you don't need to worry about checking if there's one, two, or no triangles. Again, that's always only the case for SSA. So good luck the rest of the way.